Hello everyone, welcome to free crash course for competitive exams held by Virat Hindustan Sangam in association with Manifest IAS Bengaluru. This program is inspired by Dr. Subramaniam Swamy and is convened by Ravi Shankar Sir, State Education Convener for VHS Karnataka branch. You can watch this entire program online free of the cost on the YouTube channel of Virat Hindustan Sangam, also on the YouTube channel of Udaya News Karnataka. For further any queries, mentoring, any guidance you need from our side, you can join our Telegram channel, VHS Education Forum. So I am the chief mentor of your program. I have been mentoring competitive exam aspirants for past 5 years. And we are done with polity, history and economy and negotiating the geography. The source for your geography is class 12 and class 11 and class 12 NCRTs. Those are more than sufficient. If you want to read any additional reading for physical geography, you can read this book, Go Ching Liang. But this can be taken up as a secondary reading, and you can take up the class 6 to class 10th NCRTs also as a additional reading, right? But when it comes to geography, the most important thing is the atlas, maps you have to know, right? Okay. So yesterday we were talking about geomorphic processes. Geomorphic means something related to earth. Earth is called geo, right? So geoid, earth shape is geoid. So something related to earth is geomorphic, earth building process. What are the changes that are happening on the landscape of earth, interior as well as exterior? So yesterday we discussed about igneous rocks, sedimentary rocks, rock cycle, metamorphic rocks, all those things. Now I'll be taking up the concept of weathering. So first we should know what is the difference between weather and climate. Weather means short-term phenomena. Over a day, over an hour, what is the change in the weather, right? What is the change in the moisture, temperature, all these things is called as weather. But change over a long period of time is called as climate, right? Long period changes is climate, or short period changes in the atmosphere is called as weather, right? So this because of this weather and climate, because of these changes, the rocks will be reduced into fragments. The big rocks will become small fragments, right? They will be reduced into fragments. So this is can be either because of two processes. One is mechanical disintegration. Mechanical disintegration means because of some pressure, right? Suppose a rock is there and another rock is going to come and fall on it, right? So because of mechanical processes, physical processes, if a change or a weathering takes place, that is called as mechanical weathering, right? And one more thing is chemical decomposition. Rocks will also undergo chemical decomposition. We will look into how the rocks will decay chemically, right? So this weathering is a in situ process. What is in situ process? It happens, see, wherever the rock is there, that there itself weathering will happen. The rock need not be taken somewhere else for the weathering to happen. So if the changes or the weathering process happens at the same place where the rock is located, that is called as in situ process. Suppose the changes happen somewhere else, that is ex situ process. In situ means in the same place where it is located. Suppose a rock is located here, it will disintegrate into sand or mud at the same place, right? It won't change its position, right? First we will look at the process of chemical weathering. So chemically how the rocks will weather. So first you have water. Water and heat are the two things, two elements which will speed up the process of weathering, right? Water and heat, they speed up the reaction. So if you have studied chemistry in your school days, they would have told that if you increase the temperature, chemical reactions will speed up, right? So that is the concept behind this. So the first process of chemical weathering is solution. Solution means some chemical will be dissolved in the water. Some chemical will get dissolved in the water or acid and it will become a solution, right? Any material, any molecule or element will get dissolved in the water and or acid, it will become a solution. Those solution, when it goes and affects the rock will disintegrate. based on solution based disintegration. Clear? So when this solution goes and touches the rock, the rock will dissolve. That is the solubility. Solubility means how the rock will react with the solution, right? So that is the concept. So whatever in the water or acid, whatever the chemical element or something you put, right, material, that is called as suspension material. Suspension material will be there in the solution, right? That will hold together, will become a solution and it will affect the rock, right? So what are the chemicals, material which will be put in the water? Nitrates. Nitrates can be put in the water or acid to become a solution. Sulfates can be put into it. Potassium can be put into it in order to form a solution, right? So even you in rainy climates, there is a process called as leaching. Leaching means what? So it is a form of disintegration. So you take a sugar cube, right? If you place it in the air for 2-3 days, what will happen? It will slowly dissolve because of the reaction in the atmosphere. Likewise, if you have a also you take this example of apple. If you keep the apple outside for long, it will slowly the color will change, right? The upper layer, removing of the upper layer is called as leaching, right? So leaching will happen in the rainy climate. That leaching of the rocks is also because of the solution, because these chemicals will mix with the water and dissolve the rock. So what are the chemicals which are going to dissolve the water? It is calcium. Which rock will dissolve? The rocks which contain the calcium carbonate. So rocks having the calcium carbonate will dissolve with the solution process. So calcium carbonate is the rock in this process, right? So and the solution is the carbonic acid water. So that means carbon dioxide dissolved in the water, right? In the acid, carbonic acid water will dissolve the, what will it dissolve? Carbonic acid water, it will dissolve the calcium carbonate, right? So this is the process of solution. Next you have carbonation, right? Here also there is a element of carbon dioxide dissolving in water or acid, right? What is this carbonation? Reaction of carbonate and bicarbonate with minerals, right? Bicarbonate elements or the carbonate elements, if it reacts with the minerals in the rocks, right? So that will lead to what? Carbonation, right? In carbon, which are the rocks which will be dissolved in this process? It is the feldspar or the carbonate rocks. Carbonate rocks or feldspar rocks will be dissolved by the, or weathered or chemically weathered by the carbonation process. Here carbonic acid will be the solution. Carbonic acid will form the solution to dissolve the rocks. So you see the cave formation, cave in the rocks, right? This will be especially seen in the limestone rocks. Limestone rocks, you see a form of cave forming. That cave forming is because of the carbonation. So here, where do this carbon dioxide come from? So naturally also this process is happening in the nature. So it happens by decaying organic matter, so you have these leaves, all these things, dead plants, animals, they will decay. When they decay, what happens? They release the carbon dioxide. They mix with, they react with the what? They react with the rocks and they are going to dissolve, or they are going to cause the effect of carbonation, and the rocks will be chemically weathered. This is the process of carbonation. Next is hydration. Hydration means something related to water, right? If the rocks dissolve or rocks disintegrate because of water, because of the action of water, it is called as hydration. Chemical addition of water. If you add water to the rock, if it disintegrates, that is the process of the hydration. So when you add water to some rocks, for example, you have sandstone, limestone. Limestone, if you add water, what happens? It is going to expand, right? So expand the materials. If you add the water, they will expand, right? Which are the rocks which are going to disintegrate by the process of hydration? It is, see, earlier calcium sulfate will be there, that will get converted into gypsum. Calcium sulfate rock getting converted into gypsum is because of the addition of what? Water, right? This is the chemical weathering process with respect to hydration. So see, when you add water, what happens? A rock will expand, right? Some rocks, not every rock, soft rocks, right? But when the rocks become dry, they will contract. Because of the frequent expansion and contraction, what will happen? There will be lot of stress, and when the stress builds up, there will be fatigue. Fatigue means it is a kind of stress. So when fatigue happens, the rocks will disintegrate because of frequent expansion and contraction. So what is the here you have clay. Clay will, if you add water to the clay, it is going to expand, or if it becomes dry, it is going to contract. Likewise, clay will also what? Clay will also react to the water hydration process. So next is salt in pore spaces. So you take, if you want to take the example of this water, the best example is, see, there is a rock. In this rock, there will be small pore spaces like this, right? So in these pore spaces, what happens? Water will go and get collected. Because in that water, what happens? When the water freezes, what happens? It is going to contract. When it becomes ice, it is going to contract, right? When it loosens or when it dissolves, right? So it is going to, when it gets converted from solid ice to the water, it is going to expand, right? So because of this frequent change, contraction and expansion, here this space will become bigger. This pore will become bigger and the rock will cut open. Similar is the process with respect to salt. If there is salt, any salt in the rock spaces, if this is a rock, this is a small wedge, small opening. If there are salt elements here, right? So salt solution will also expand and contract. So when it expands and contracts, this pore space will cut open and the rock will disintegrate. This is the process of hydration. Next you have oxidation and reduction. Oxidation means addition of oxygen, right? Reduction means removal of oxygen. So which are the elements, which are the rocks which are going to are susceptible to oxidation and reduction? It is rocks or minerals with iron, manganese and sulfur. These are the three rocks susceptible to oxidation and reduction. So when there is excess oxygen, oxygen will be there where? It will be there in the air or it will be there in the water, right? So when these rocks will be rocks come in contact with this air or water, what will happen? It will get oxidated, right? On the other hand, if you remove all the oxygen and place the oxygenated, see, this iron after oxidation, it will become brown. It will be initially it will be red. So rusting of iron. So rusting of iron, it is because of oxidation. So iron will become red to brown after oxidation, right? So what happens? Once the iron is oxidated, so if you keep the oxidated iron in an oxygen-less atmosphere, it will undergo reduction. So in order to undergo reduction, reduction means removal of oxygen, right? In order to undergo reduction, what should we do? Oxygenated element, mineral, should be kept in a place where there is no oxygen, right? So that is the process. So red to brown color of the iron is because of oxidation, and also oxygen, if it is absent, it will lead to reduction, right? Okay. Next, we will look at the physical weathering process. So chemical weathering is done. Chemical, it is because of chemical reaction, hydration, carbonation, solution, right? So these are the what is the one more? Oxidation and reduction. These are the 4 chemical weathering processes. Now we have physical weathering processes. What are the physical weathering processes? One is mechanical weathering. I told you, mechanically if the rock disintegrates. If a big animal keeps its leg on a rock, the rock will cut open. That is also mechanical weathering. It is because of what? Because of pressure, applied pressure. So gravitation. See, because of gravitation, what happens? The rock will be pulled downwards, right? There will always be pressure on the rock towards the earth because of gravitation. Also, if on a rock, if you place some load, if there is a rock, gravitation will be acting in the downward direction. On the rock, if you place some material, that will act as a load, right? That will act as a load. Both of these will lead to stress in the rock. Because of this stress, the rock will break open and the weathering will happen. So, what are the expansion forces? Expansion of the rock. What are the forces that are there? One is temperature. Temperature. If the temperature changes, mechanical weathering happens. Or animals. I told you, if an animal meddles with a rock, it will cut open, right? That is also a process. And also crystal growth. So, I told you, the rocks will be formed out of crystals, right? So, those crystals, if they grow, right, because of any changes, that will also lead to mechanical weathering. So, water pressures. Water pressure is also the example. What is water pressure? Wetting and drying. So, suppose let's say there is a rock. So, on this rock, there will be rain today and afternoon it will be, so you have equatorial regions. In the equatorial regions, there will be daily rain, daily huge sunlight. So, daily the rock will get wet and daily it will be dried. So, because of this frequent wetting and drying, what happens? The rock will cut open, right? That is the process of mechanical weathering, right? So, the rock will change at the surface as well as within. Outside, rock will change on the outside also, as well as the weathering will happen within also, right? Thermal expansion. So, because of heat, I told you, because of temperature, there is a change. Because of temperature, what happens? The rocks will expand. When the temperature increases, the rocks will expand. That is known as thermal expansion. And one more thing is pressure release. What will happen in pressure release? So, let's say on this rock there is lot of pressure. On this rock there is lot of pressure. Let's say a bigger rock is there. If you suddenly remove this rock, what happens? Pressure is removed out of the rock, right? So, it will expand. So, the pressure is released, then also the weathering will take place. So, that we will discuss under unloading and expansion. When a load is there on a rock, if you remove the load, it will expand, right? So, overlying rock is removed. When the overlying rock is removed, pressure is released, right? When the pressure is released, what happens? Upper layers of the rock will expand. When the upper layer of the rock expands, it will lead to disintegration. Upper layer of the rocks expands means, so this rock is removed. So here only this rock will be left. So what will happen? This will lead to disintegration, right? So it will lead to parallel fractures. So in this rock there will be fractures like this, right? So parallel fracture, the best thing is not vertical, it is actually horizontal. If a rock is there, if there is some bigger rock, if you remove that rock, the pressure is released. Here on the upper layers will expand. When the upper layers expand, what happens? This layer will cut open. Parallelly, there will be a fracture because of the release of pressure. A fracture will happen. That is known as exfoliation slab. The cutting open of the rock because of the release of upper pressure parallelly is known as exfoliation. So, the parallel fracture is known as exfoliation slabs. Very, very important, right? This rock will be cut open here and there will be a crack. If you see a big mountains, right? So, it will be crack will be there like this on the upper layer because of removing of pressure. So, what are they called? They are called as exfoliation slabs. So, you have exfoliation slabs are smaller on the smaller rocks. If it is on a bigger rock like a mountain, that is called as exfoliation dome. Exfoliation slab and exfoliation dome, right? Next you have temperature changes and expansion. What will happen when the temperature changes? How does the expansion will take place in the rock? So there are various minerals. See, in a rock there will be multiple minerals, right? So because of these multiple minerals, what happens? There will be because of temperature change, various minerals will react differently. So when they react differently, there will be expansion within the rocks, right? So best temperature change is diurnal change. What is diurnal change? Day and night change. The change of temperature between day and night is called as diurnal change. So because of diurnal change, there will be temperature change which will lead to expansion. So there will be internal movement within the rock. Internally, see the rock minerals, the crystals of the rock will be arranged like this in the rock or in some other direction. Because of temperature change, what happens? These crystals will reorient, right? There will be a internal movement within the rock, right? This will happen, this temperature change you can witness especially in the dry climate regions. So in the dry climate, in deserts and all, what happens? Because daytime will be extremely hot, night time will be extremely cold, right? That is the diurnal change, right? So this is also witnessed, temperature change is also witnessed in the highly elevated regions, right? So because of this, there is exfoliation. Exfoliation similar to the unloading and expansion. Even in temperature change, exfoliation will happen. Because of exfoliation, what happens? The heaving and fracturing parallel to the surface. Heaving and fracturing means the rock will cut open parallel to the surface. This is parallel, right? Parallel. So the rock will get cut open parallel to the surface, right? Surface ke parallel agi, it is going to cut open. That is the concept of the exfoliation. So smooth rounded surfaces. This will be a smooth round surface. Exfoliated slabs will be in the form of a smooth rounded surfaces. So if granite rock gets exfoliated, it is called as tors. Granite rocks getting exfoliated is called as tors. So next you have freezing, thawing and frost wedging. So what is wedge? So wedging means, see, you have this, there will be some iron equipment like this, right? So they will keep it in front, in the middle of something, and they are going to hit it with hammer, right? So there will be something like this. If they hit it with hammer, this will cut open this material, right? So this is called as a wedge. So what happens if there is a rock and there is a wedge like this, small wedge? So what happens? Water will get into it. When the temperature reduces, water will freeze. When the temperature increases, water will expand. I mean, ice will expand, become water, right? Because that is the process of freezing. Freezing means water in this pore space getting contracted. Later on, it is expanding. Thawing means expanding, right? And frost wedging, because of this contracting and expanding, there will be frost wedging. Wedging means it will cut open, right? So there will be ice within these pores. This ice will contract and expand, right? This is observed in the higher elevations. Higher elevations, mountains and all, you can observe this freezing, thawing and frost wedging, right? So rapidly it is going to freeze and suddenly the water is going to expand, because of which what happens? There will be the process of weathering. So this is the fourth process, right, under physical weathering. Then is salt weathering. Salt weathering similar to the chemical weathering. What happens? Temperature change. Because of, see, there will be salt crystals within, I told you, similar to the chemical weathering, there will be salt crystals. Temperature, hydration and crystallization. What happens? This salt mixed with water, right? What happens? It will become salt water, and it will, when the temperature increases, the water will evaporate and it will become what? Crystals, salt crystals. So there will be salt crystals when the rain gets into it, it will become salt water. When it evaporates, it will become again salt crystal. Because of this temperature change, the frequent hydration and crystallization of the salt, what happens? The rock will cut open. Right? This is the salt weathering. So which are the salts? Calcium salts, sodium salts carry out this process. Right? So this is witnessed in the deserts. Salt weathering is witnessed in the desert regions. Right? So surface pores. In the surface there will be small pores. So in those pores there will be splitting of the splitting and falling of the. So what happens? See, here salt water will be there. This salt water after evaporation it will undergo recrystallization. When water gets into it, it will become again salt water. Right? What happens? Because of which there will be this small rock fragments will be there. Right? Those small rock fragments will fall off. They will split out of the original rock and it is going to fall off. That is the process of splitting and falling because of salt weathering. Right? This is also called as granular foliation. Granular foliation means granularly, that is rocks, small granules of the rocks will be cut open. They will cut open and fall. That is the process of granular foliation. Right? This is because of frequent wetting and drying. Frequently wetting and drying will happen. That is why this salt weathering will take place. So this is also called as heaving and cracking. Heaving and cracking means this process of cutting open is also called as cracking or heaving. Right? Okay. This is so heaving generally means it is the lifting of something. If you lift something, it is called as heaving. So here these small rock fragments will cut open and fall. Right? That is one thing. Second one is cracking. These rock will get cracked. So these are the processes under salt weathering. So also called as heaving and cracking. Next you have biological activity and weathering. What is the biological activity and related weathering? See, in the rocks what will happen? In the soil there will be lot of microorganisms. Right? So there will be small organisms, there will be leaves, so many organic material will be there. So what these also these mice, rodents, rats, all these things, rabbits, what they do? They will burrow. They will create holes in the sand. So because of that also, because of animal action, because of plant action also, what happens? Weathering will happen. See, if you know a plant, if you have seen a plant, coconut tree, what happens? The roots will be very widespread. So when the roots spread out widely, what happens? It is going to cut open the soil. Right? It is going to break the rocks as well. The roots will be so strong. That is the process of biological activity and weathering. So movement of organisms. Right? Small microorganisms. Your earthworms, rabbits, rats, right? Rodents, all these will be what they will do. They will frequently change the surface of the earth. They will be frequently moving out, in and out, right? So this is biological activity is both physical and chemical. So a root of a plant opening the soil is a physical process. Chemical process is what? Chemical process is if the leaves of a plant decay. Because of the decay, what happens? The rock changes, means that is if because of decay, what happens? Carbon dioxide will release. When carbon dioxide releases, there will be the process of carbonation, right? Under carbonation also, chemical weathering, there will be the process of weathering, right? So biological activity, it will lead to both physical weathering as well as chemical weathering. So I told you burrowing means the animals opening or good ಮಾಡ್ಕೊಳ್ಳಲ್ವಾ bilatodi, that is burrowing, right? Opening the surface of the earth to create their create the places where they live, holes, small holes, that is burrowing. And wedging, right? So what happens? Because of this, new surfaces will be exposed to moisture and air. So the new surfaces within the earth will be exposed to the outside moisture and air, and because earlier those surfaces were not visible, because these animals burrow the earth, what happens, new surfaces will come up and it will lead to changes, it will lead to weathering, right? Humans also cause weathering, right? So we will shift the rock from one place to other place, we will put the dynamite and blast it. So we are also causing the weathering process. Also decaying matter, I told you, if a leaf decays, it releases carbon dioxide, that will lead to weathering process, that is the decaying matter. Plant roots also change. Plant roots are also responsible for weathering. The best example is the coconut palm. Next you have effects and significance of weathering. So what are the effects of weathering? Because of weathering there will be change in the landscape. So rocks will, what was the rock earlier will become soil later on, right? So also it will lead to formation of good quality soil. It will lead to formation of new soil, right? So these there are multiple effects. It will lead to formation of new relief, new landscape, right? All these are the effects of the weathering. So what is the significance of weathering? So whatever the effects I told, they can be applied for significance as well, because we need fertile soil. Where does it come from? It comes from the weathering process. That is a primary significance. So the rocks will undergo weathering. When weathering will happen, the rocks will, later on erosion will take place. From the place of weathering there will be erosion of the soil. So that will take place. There will be new soil formation, right? There will be mass wasting. Because of weathering, mass wasting means it is just like landslide. Mass wasting will be there. There will be relief reduction. Relief reduction means if there is a big mountain, because of weathering, it will become a plain. So all these are the benefits, right? Ore concentration. See, ore concentration means, see, earlier, the let's say there is a iron ore in the rock. What happens? So it is in the rock, it will be, if this is a rock, let's say iron ore is spread like this. So because of weathering, what happens? If all the rock material are removed, only iron will be left out. So iron ore will be concentrated because of the weathering process, right? So this is the iron ore concentration or ore enrichment. See, iron is getting enriched here, right? If you remove some the impurities, the ore will get enriched. So that is the process of ore enrichment. Next you have the process of mass movement. What is mass movement? Mass wasting, mass movement. So here, till here is the your weathering process, right? Next we will look into mass movement. So what is mass movement? So this mass, see, weathering will take place under chemical or physical processes, mechanical or chemical processes. So there might be temperature change, pressure change, or there might be biological activity, or there might be various other processes because of which weathering might take place. Whereas when it comes to mass movement, this will happen because of gravity. Mass movement takes place only because of the effect of gravity. Without gravity, mass movement will not take place. For now, just understand mass movement as a something similar to landslide, right? So here there will be no geomorphic agent. Geomorphic agent, like there will be no air, there will be no wind, right? There will be no ocean or water, right? There will be no water, right? There will be no tides or something. So there will be no geomorphic agent to carry out the changes. It is only because of gravity mass movement will take place. So the mass movement can be either slow or rapid. So the landslide can be sometimes slow, sometimes rapid, right? So there are various concepts of mass movement. We will look into it. So here, in order to mass means there is some amount of Earth's mass. It will move from one place to other place. That is mass movement. So that for that weathering compulsory for mass movement to take place? Should there be a weathering before the mass movement take place? Actually, weathering is not a compulsory. So without weathering also mass movement will take place. With weathering also mass movement is going to take place, right? So weathering is not a prerequisite, but it will aid it. How it will support the mass movement? Because let's say, see, there is weathering. If there is weathering and the rock will become soil, right? So it will lead to easy movement of earth from one place to earth, because one place to other. Because why? If there is proper rock, solid rock, it is difficult to move from one place to other place. But if it is weathered into small particles of soil, it is easy to transport from one place to other, right? So mass movement is going to aid the, or weathering will act as an aid to the mass movement, whereas it is not prerequisite, right? So this mass movement, it is active over weathered slopes. Wherever weathering has taken place on the slopes of the mountains, you can witness the mass movements, right? So here there is no erosion. See, for erosion, what do you need? You need water or some material to carry the mud or sand or clay along with the eroding material, right? So water should carry the mud or sand along with it. Whereas here there will be no erosion because there is no geomorphic agent, right? So in this mass movement, the material will overcome the resistance. So earlier what happens? The material will be here, right? So there will be gravity acting like this. So what happens? There will be initially resistance. So once this resistance is overcome, what happens? This material will fall. So there will be a resistance which needs to be overcome, right? So next you have, what are the causes, activating causes for the mass movement? One is remove the support. What do you mean by removing support? See, for the weathering, for the mass movement, see there is a rock here. So this rock will be supported by some materials like this. So it is not falling down. So if you remove the supporting material, the rock will fall. So that is one thing, activating cause. Then increase the gradient. So if it is a flat surface, the mass movement will not take place. If this rock is on a surface like this, so it will easily fall. So gradient should be increased, or there should be lubrication. So if it is moving on a dry material, it will be very difficult to move. Suppose there is ice here or water here, so it will easily slide. So lubrication is going to add the mass movement. Then removal of load. Removal of load means, let's say here there is this material and over this there is one more material, right? So if you remove this overhead material, here this material will be there. Because of this overhead material, this rock is not moving. If you remove this overhead material, this rock will easily slide. So it will lead to mass movement. Earthquake will cause vibrations. Because of vibrations, the mass will be moving, rock will be moving. Then no natural vegetation. See, on this slope, if there is a tree, it is not going to help the mass movement because it is going to stop the rock. Whereas if there is no natural vegetation, it will be easy for mass movement to take place, right? So this is the basically mass movement. This is the diagram. So see, first you understand this denudational processes, geomorphic process. First is weathering. For weathering, there should be chemical reasons should be there, gravitational reasons might be there, mechanical reasons might be there, or molecular stresses. The stresses in the molecules of the rocks might be there. So that is the reason for the weathering. Whereas for mass movement, the sole reason is gravitational force, right? For erosion and transportation, the sole force is kinetic energy. For a material to transport from one place to another, what energy you require? require kinetic energy, right? So this is the process of mass movement we will discuss. First you have, so this is the speed, fast speed, slow speed. If the masses, if the soil or rock, it is going to move slowly. If it is going to move slowly, it is called as heaving. Moving slowly, heaving. So if it is going to move fastly, it is going to move fastly means it is called as flow, right? So if it is flow means over the surface, right? Flow will happen when there is wet surface. But if there is a dry surface, what will happen? It is going to slide, landslide, just like slide, it is going to slide. So slide will happen. The best example is rock slide, landslide, all these things. The best example for flow. So flow under wet condition is, which is fast, mud flow or earth flow, right? So solidification, here the slow process is soil creep. Soil creep means the soil will move slowly. If you see the valleys, so there will be pillars like this, or light poles or lighting, these things will be there, or there will be what? This fencing or fencing around the houses. So on these poles, generally what happens? Here you will find lot of soil getting accumulated next to the pole, right? So this is called as what? Soil creep. Soil is going to on the compounds. So if you see houses on the valleys, so on this side you will find lot of soil getting accumulated. That is soil creep. So soil talus creep is something, a rock is going to creep, that is called as talus creep. Solidification. What is solidification? If the soil is going to move aided by a material, if the soil gets mixed with the water and moves, it is called as solidification. So there will be ice or water over which the soil moves. That is called as solidification, right? So this is the process. Next you have the slow movement. Slow movements, I told you, creep. Creeping is a slow movement. It happens over a moderate slope. Moderate slope means neither too steep nor too plain. Something this in this direction. So that is moderate slope. Creep will happen. So what are these things? Processes: soil creep, rock creep, all these things. So I told you fence example. Next you have solidification. Soil mass saturated with water. If the soil is filled with water, it will lead to solidification. Then this is solidification can be seen in the which temperature? Moist temperate regions. Then you have rapid movement, fast movement, you have steep slope. In these slope regions, you will find the, what do you find? You will find rapid movement, rock slide, landslide, all these things. So for rapid movement, you will find it in the humid climate. What do you mean by humid climate? So what is humid climate? Humidity. If there is too much water vapor content in the atmosphere, it is called as humidity. If you go to Mumbai or Chennai, you will find the heat. You will sweat a lot because in the water there will be what? In the air there will be lot of water content which will make you sweat, right? That is the humidity. In the humid climate, you will find this rapid movement. So water saturated clay. If clay is saturated with water, clay gets saturated with water, it is called as earth flow, right? So step-like terraces and there will be step-like terraces and accumulation bulge at the toe. So what is this step-like terraces? I will draw you the diagram and show you. So it is like this. See, if the soil or the rock is going to flow like this, see what happens? Here there is lot of accumulation. This is the accumulation toe. Whereas here what is there? There will be step like terrace, steps like can you see the steps? So if the soil is going to, land is going to slide, here it will get bulged. It will get swayed here. Here there will be step like terraces. Right? This is the process. I will discuss the diagram again. So accumulation bulge at the toe. So or there might be rock slide as well. Then is mud flow. When does the, in the rapid movement, one more process is mud flow. When does the mud is going to flow? When there is no vegetation, when there is no grass, there are no trees, then there will be mud flow. So when the mud is saturated with water, when the mud is filled with water, it is going to flow. That is the process of mud flow. So you can find the stream of mud in valleys. So what is a valley? What is a valley? If there are two mountains, in between the mountains, this space is called as a valley. Right? So in the valleys, there will be stream of mud. So if the mud is going to come like this, it will get accumulated in the valleys, right? So there will be stream of mud in the valleys. This is actually very destructive. This stream of mud is very, very destructive. So if there are people here, it is going to kill them. It is going to bury them alive. Then also mud flow you can also find in the volcanoes. When there are volcanoes, during the volcanoes expansion or explosion, so there will be flow of mud. There will be flow of pyroclastic material, volcanic ash, all those things. Along with that, mud is also going to flow. Next you have debris avalanche. What is debris avalanche? So debris means, in today's context, debris means all the plastic, paper, all these waste material you can call as debris. But in the nature's context, debris means all the rocks, soil, right? All these material of the leaves, everything. So all these things, if it is going to come down at once. So avalanche means what? So you know snow avalanche, right? Snow. So when the snow avalanche means entire ice is going to come down like a river, right? That is snow. Similarly, there will be debris avalanche, that also comes under rapid movement of earth, right? So this debris avalanche you can see in the humid regions where there is lot of humidity. There you can see the debris avalanche. This can be seen on the steep slopes, right? Debris avalanche, something not in this moderate slope but in the regions of steep slope. This debris avalanche is a faster process. It happens very faster, right? Then you have landslides. What are landslides? These are rapid and perceptible. See, creep process you cannot see easily because creep process is very slow, right? Whereas this landslide you can see with your eyes. So because it is rapid, very rapid, and you can see it with your eyes. So in the landslide there will be dry material. What is going to slide along in the landslide? It is the dry material, right? Whereas in solifluction, it is soil mixed with the water which is going to flow. Whereas here in the landslide, it is the dry material which is going to flow. Then you have the question of slumping, slipping of the rock with backward rotation, slump. The best example, slipping of rock. Rock is going to slip but with backward rotation. So see this example. See, rock is slipping here, but here there is backward rotation, right? So this is rotating in the backward direction because of slipping. This process, this region, right? This is the slipping of the rock with the backward rotation is known as slumping. Slumping of debris with backward rotation. See, this is the diagram. Next you have debris slide. So what is the difference between slump and a debris slide? What is the difference between slump and a debris slide? See, in debris slide, there will be no backward rotation. In the debris slide, the rock will not go down with the backward rotation. See, here there is backward rotation as I showed it to you. But in the debris slide, there will be no backward rotation. It is just going to slide like that. That is the debris slide. Then debris fall. What is debris fall? See, if there is a cliff here or a mountain, if there is debris, if it is just going to fall down the cliff, that is debris free fall. Then you have individual rock, if it is going to slide on the mountain, individual rock is sliding on the mountain, it is called as rock slide. If it is going to fall freely, it is called as rock fall, right? So Himalayas and debris avalanche and landslides. What are the reasons? In Himalayas, you find lot of debris avalanche and also landslides in the Himalayas. What are the reasons? See, the primary reason is Himalayas is a tectonically active region. Tectonically active region means there is lot of earthquakes, internal earthquakes. Every moment the earth will be shaking there, right? It is a tectonically active region. So that is why there is debris avalanche or landslide in the Himalayan region. That is the first reason. Next you have the climate. The climate itself, because there is lot of rivers, right? Lot of water, lot of glaciers. That is the second reason for the most of the landslide and debris avalanche in the Himalayan region. Second reason. The third reason is human intervention. Human causing problems in the region. That is also a reason for, and also heavy rainfall or snowfall in the region. That is also the reason for debris avalanche in the region. Also the slopes are very steep in the Himalayas. That is also reason for the debris avalanche and landslide. So Western Ghats, what are the reasons for landslides? In the Western Ghats, landslide happens. What are the reasons? So in the Western Ghats, it is steeper slopes. So even though Western Ghats, there is no earthquake, just like Himalayas. So why in the Western Ghats also there will be landslide? You see in the Pune region, every frequently in the Western Ghats there will be Sahyadris, there will be landslides. So even in Kerala. So what is the reason? The slopes are steeper. Western Ghats slopes are steeper, right? That is the reason. And also because of temperature change. Because of temperature change, what happens? There will be expansion and contraction of the rock material. Because of which, what happens? There will be debris avalanche or landslide in the Western Ghats region. Next you have heavy rainfall. If there is heavy rain, because Western Ghats, because of the monsoon rainfall, there will be heavy landslide in the region. These are the reasons with respect to Western Ghats and Himalayas. Then you have erosion and deposition. So you have erosion and deposition. So what is eroded? See, when the weathering happens, when a rock weathering happens, it will form into small fragments, right? The rock will break into small fragments. That rock debris will be eroded from one place and deposited at the other place, right? That is one thing. So this rock, see, when this rock debris, if it is moving, if the rock debris is moving, what will happen? It will move over some surface. So on the surface, it is going to cause friction. When the rock fragments causes friction, it will lead to abrasion. Abrasion means scratching of the surface. Because of scratching, what happens? There will be more material which will be plucked out, right? So that is the abrasion by rock debris. So because of erosion and deposition, what happens? There will be degradation of relief. Means what? If there is a mountain like this, because of erosion and deposition, this mountain will become flat. That is the reason. So erosion is largely responsible for degradation of the relief. Then kinetic energy. So when the erosion takes place, what happens? This mountain will be reduced because of weathering, and there will be erosion. That erosion will happen because of the kinetic energy. So what are the materials involved in erosion? It is wind, Wind is going to cause erosion. Take the material in the desert region. Take the sand from one place to other place. Wind is responsible. Water is responsible. Right? Glaciers are responsible. Glaciers are also going to take the material from one place to other place. Then also waves are also responsible. Groundwater is also responsible for the erosion and deposition process. Right? So why do deposition takes place? See, here there is a mountain, here there is one rock. So this rock will break into multiple pieces. There will be water. This water is going to carry this material, and while carrying, this will scratch these rock fragments will scratch the surface and take some more material along with it. So when it reaches the surface, when it hits the surface, what will happen? This water will lose velocity. Speed will get reduced. When speed will get reduced, what happens? All these fragments get deposited because there is no speed. Deposition takes place due to losing of velocity on a gentler slope. This is a gentler slope. This is a steep slope. So on the steep slope, it will move faster. On the gentle slope, because they lose velocity, what happens? There will be deposition will take place, right? So there will be both coarser material and finer material. What is coarser material and finer material? So in the erosion, there will be material which are big in size. Also there will be material which are small in size. So both of these things will lead to erosion and deposition. Next you have soil formation. How soil is formed? The process of formation of soil is called as pedology. The study of rocks is called as what? Petrology. The process of study of soil is called as pedology. So this soil formation is a dynamic process. Dynamic process means there will be lot of changes when the soil is formed, right? It is not a static process. There will be temperature change, there will be volume change, pressure change. Because of all these changes, there will be the soil formation will be dynamic. It's a dynamic process. So this can be both. Soil formation can be because of chemical process. I told you, chemical weathering, or it might be because of physical weathering, or it might be because of biological activity as well, right? So in the soil there will be decaying. The soil will be formed because of the rock or organic material decaying, right? So this changes with the season. So in the summer season, the decaying will be more. Suppose there are leaves in the soil. In which season are they going to decay faster? In the summer season, they are going to decay faster. The winter season, the decay will slow down, right? So this is a process. Then process, how does the soil is formed, right? First there will be weathering mantle. Weathering mantle means there will be some rock. That is called as weathering mantle, right? This is colonized by bacteria or plant, right? Some bacteria or plant is going to come here on the soil rock, right? And humus will get accumulated. Humus means gobra. So humus or leaves, dead leaves, degraded leaves will get accumulated, and slowly it will lead to either chemical weathering or physical weathering or biological weathering. In this process, it is biological weathering. The rock will get converted into soil, right? So here, what are the important things with respect to soil formation? The first and foremost important thing is parent material. Parent material is what is the rock's original material? Is it made of iron? Is it made of magnesium? What material it is made of? That is the parent material, right? This is a passive factor. Passive factor means it is not an active factor, because active factor means what? It is going to directly influence the formation of soil, whereas the parent material is a passive factor. It is not going to directly influence, because all types of rocks will be eroded. Hard rocks will be eroded slowly, soft rocks will be eroded very quickly, right? So it is a passive factor. What all depend parent material? It depends on the texture of the parent material. Texture means if you hold a material, how does it feel? That is the texture. Or when you see a material, how does it look? That is the texture, right? Texture of the material, or structure of the material, structure of the rock material, or mineral and chemical composition. What is the mineral composition of the parent material? What is the chemical composition of the parent material? That is also going to affect the soil formation, right? So parent material will influence the nature and rate of weathering. I told you, if it is a hard rock, the rate of weathering will be fast. If it is a soft, it will be quicker, right? Then also whether it is a chemical weathering or physical weathering or biological weathering, it will be dependent on the parent material, right? So there will be depth of weathering. Depth of weathering means if a rock is like this, so till what depth it will be weathered, that is depth of weathering. Then show relation with parent rock means what? This whatever the material that get weathered, it will have a relationship with its parent material, right? If a rock is here, it gets eroded and small fragments will be lying here nearby. So if you check the relationship, both will be the same rock. So it shows the relationship with the parent rock. Also, the soil formation will depend on the topography. Topography means the climate, the relief, right? The weather, all those things are going to affect the soil formation, right? So exposure to sunlight. So how much the rock is getting exposed to sunlight, how much it is getting exposed to water or drainage, that will also affect. Also, the soil formation will be thin over steep slopes. See, if there is a steep slope like this and there will be flat surface like this, on which surface will be the soil thicker? On the flat surface, the soil will be thicker. On the steep slope, the soil will be in a thin way, right? So thin over the steep slopes. So in the gentle slope, so if there is a gentle slope, what happens? It is favorable for soil formation, gentle slope, right? So flat areas are also favorable for soil formation, flat areas, right? So the direction of the slope is very important for the soil formation. Direction of the slope, sunlight, all these things are very important. Then climate is also very important. What is the moisture in the air, right? What is the duration of precipitation? How much rainfall is going to fall, right? That is one thing. Then how much evaporation is going to take place? How much evaporation is happening in the region, right? How much temperature change is happening in the region? All these things will affect the what? All these things will affect the soil formation, right? So you have this process of alluviation and illuviation. So what is alluviation and illuviation? See, illuviation means top to below deposit, right? So means, so how do I explain this? I think I should put a diagram. I'll draw the diagram and show you. Okay. See, if there is a layers of soil like this, layers, multiple layers, this is earth surface, right? So this soil getting top soil getting deposited at the bottom is called as illuviation, or bottom soil getting deposited at the top is called as elevation. Soil at the bottom coming up is elevation, top soil going below is elevation, right? That will also affect the soil formation. Then desilication due to rain. If there is rain, because of rain, the soil will lose the silica content. That will also affect the soil formation, right? Then capillary action. Capillary action means what? See, in the dry region, what happens? The soil, water in the ground, that it will come up in the dry region and all the salts will get accumulated. See, if there is a dry region, water will be underground. It will come via the small pore spaces to surface and evaporate. When it evaporates, all the salts will get accumulated. That will also lead to, so when capillary action takes place, there will be leftover salts. So when the leftover salts is there, that is going to lead to help the soil formation. Then, so if there is one type of soil formation is because of these leftover salts, whatever the salts are left over on the surface, if it gets condensed, it is called as hard pan. Because of capillary action, whatever the salts that comes to, so water, because of capillary action, water comes to the surface. When the water evaporates, salts will be left out, magnesium, potassium, sodium, all these things. Those salts themselves forming a soil is called as hard pan, right? Also, if there is a region of intermediate rain, if there is average rain in a region, so there will be conchar nodules or CaCO3 nodules. So if a region is rich in CaCO3, calcium carbonate, so because when there is rain in that region, it will lead to conchar formation. Conchar type of soil will form in those regions. So temperature increase or temperature decrease also leads to affect the soil formation. Also biological and chemical activity. Biological activity and chemical activity is also going to affect the soil formation, right? This is with respect to the soil formation. There are some factors. Biological activity. What is the biological activity that is going to take place in a region? What are the microorganisms? All these things. That is also affect the dead plants and humus, manure. So what is the plants, dead plants and humus in a region? That is also going to affect the soil formation. Then organic acids. If there are organic acids in the soil, that will aid in decomposition. Organic acids. Organic acids means your carbonic acid, acetic acid, all these things. If there are those acids, it will lead to decomposition of the rock. That will also lead to soil formation. Then cold and warm climate and intensity of activity. See, if there is warm climate, soil formation will be faster. If there is dry climate, soil formation will be slow, or cold climate, soil formation will be slower, right? Then nitrogen fixation, there will be nitrogen fixation as well. That will also help in soil formation. So which organism helps in nitrogen fixation? It is the rhizobium. Rhizobium, it is going to take the nitrogen and fix the nitrogen in the root nodules of the leguminous plants, legume plants. You see, you know legumes, right? So ಕಾಳುಗಳು, all these ಮೊಳಕೆ ಕಾಳು, all these things comes, no, that is legumes. Legume plants, there will be, what happens, this rhizobium is going to take the nitrogen and fix the nitrogen in the roots of the leguminous plants, right? So then you have physical activity. Physical activity also leads to soil formation. For example, earthworm. Some earthworms eat the soil and they excrete the soil. That will also lead to soil formation. Time will also affect the soil formation. Time, it determines the maturity and soil profile. How mature a soil is. What is the soil profile? that will be determined by the time, right? Time will determine the maturity, how mature a soil is, and also what is the profile. Profile means what are the layers in the soil, right? There are some layers, some O, E, some layers are there. I forgot the exact order. Or some layers are there. So those layers will be determined by the soil profile, will be determined by time, right? So and also it determines how mature a soil is, whether a soil is old, whether a soil is new. That will be determined by time. So this completes the geomorphic processes. Now we will move towards the landforms and their evolution. The chapter on landforms and evolution. So what is a landform? You see a mountain, right? You see a mountain, river, valleys. So those are different types of landforms which you see around you, right? So it is a landform is a surface of earth. It is a surface or a place on earth. So what there are several landforms, or a landform can be said as a relief of a place, whether there is mountain, whether there is plain area. All this leads to the landform, right? What is the difference between landform and landscape? So in your mobile cameras you have this landscape mode, right? So what is landscape? Several landforms together form the landscape. Several landforms come together and form the landscape, right? So each landform, if you want to know what is a landform, it has a physical shape. A landform has a shape, it has a size, it has some it has a size, and also it has some own materials, right? A landform has its own size, it has its own shape, and also various materials will form the landform, right? Okay, every landform has a beginning. So landforms, they have their own history. They are not suddenly formed. They are formed over a period of time. So if you want to know a history of a landform, you have to do what? Radiocarbon dating. When you do radiocarbon dating, you know the exact history of the particular landform. What is the history of Himalayas? What is the history of Western Ghats? You can know by radiocarbon dating, right? Okay, so there will be changes in landform. No landform remains the same. So why there is a change in landform? Because of climatic changes. Climatic changes, there will be change in landform, and also movement of earth. Movement of earth. Earth might move vertically, or earth might move horizontally, plate tectonics. Because of that, there will be change in the landform, right? So every landform has evolved. No landform has remained the same. It has evolved over period, right? It has been evolving over period. It doesn't remain the same, right? Okay, so this evolution history of landform, the knowing of the evolution and its history of the landform is known as geomorphology. Geomorphology is the study of evolution and the history of the landform. So in this landform, there will be, how do the landform is formed? It is formed because of erosion, deposition, and all those things. Landform is formed, right? So running water, groundwater, glaciers, wind, all these are the erosional features, erosional and depositional features, right? So these changes in the landform, it is actually cannot be seen suddenly. If there is a change in landform, you can see it only over a large time scale, large period of time, only then you can witness a change. Now we will be telling, right? So 20 years back when I came to this area, it was full of forest. Now it is full of buildings. Like that, the changes in the landform will take place over thousands of years. 1,000 years back, there was a mountain here. There is no mountain now. Like that. Okay. This, you cannot witness the changes, right, over a small scale, right? So there are two types. One is the erosional and depositional landforms. Once there is erosion landform, another side there will be depositional landform, right? So what are the many varieties of the landforms develop? So you have what are the features which determine the landforms? How does the landform is determined? There will be folds. Folds means rock will get folded. If a rock is there, because of pressure, it will become like this. Fold or fault. Fault means rock breaking. That will also decide the landform. And also permeability. Permeability means how much the rock will allow the water to pass through. That is permeability. That will also determine the landform, right? Not only that, there are three important factors which determines the landform. One is the tectonic stability of the landmass. How stable is a landmass? Is it prone to earthquake more? That will determine the stability of the landmass, right? Landform. Then also stability of the sea level. If the sea level is stable, is it stable or is it rising or is it falling? That will also determine the stability or the shape of the landform. Then the third factor is climate. Climate is also going to determine the landform, right? Evolution of the landform, right? So we have many geographical agents which determines the landform via erosion and deposition. The first important factor is running water. Running water is the first geomorphic agent. So here this running water, generally see if there is a normal place, some hill or some plain area is there. If water is flowing, it will flow like a sheet. It will not flow over a narrow region. It will flow like a sheet. You throw water on the tar road. Is it going to go narrowly? It will spread like a big, in a big space. So that is called as sheet. Water will flow like a sheet, right? So that is one type of water flowing. The second type of water flowing is linear flow. Linear means narrowly it is going to flow. That is the second type of water flow, right? What happens? These stream channels, if it is flowing on a parallel surface, see if it is flowing like a sheet, water is flowing like a sheet, what happens? Slowly, it is going to, if this is a landscape, if on this landscape water is flowing, slowly what is going to do? It is going to cut. It is going to make the land steeper. Slowly it is going to cut in a bigger way, right? So the land will get steeper and steeper with time, right? So that is the process. So this is when there is erosion, but on the other side of erosion you have deposition. Here the water is going to erode the materials. Slowly this will become a river, right? So all these material will be taken and deposited somewhere else, right? So this is the process, right? So there will be sheet erosion. One is the sheet erosion, what I told earlier. Second one is the steep erosion or gully erosion. This is called as gully erosion, right? So next is there will be what happens. See, first there will be sheet erosion. This sheet erosion is going to slowly get converted into rills. Rills means small waterfalls. So small narrow water movement is called as a rill. So this rill will slowly get converted into a gully. So a small valley type of a thing is a rill. So this will later get converted into a gully, big space where the water will flow, right? It is get converted into a gully. Then this gully over a period will get converted into a valley. First is sheet erosion. Later on, sheet erosion will get converted into a rill. Rill will get converted into a gully. Gully will get converted into a valley. That is how there will be change, right? So, see, there are three stages of water forming. One is the youth stage, second is the mature stage, third is the old stage, right? In the youth stage, what happens? There will be, youth stage means on the mountains. When the water is flowing over the mountains, it is called as youth stage. For example, Ganga flowing in the Himalayan region, it is flowing in the youth stage, right? In the youth stage, what happens? There will be steep cutting. Steep cutting means this type of cutting. V-shaped cutting of the valleys will take place because there will be, the gradient will be steep. When water flows over this, steep, what happens? So first it will be flowing over sheet, later it will form a gully and a valley. So what happens in the steep region or the Himalayan region or the young stage of the river, what it will going to do? It is going to do steep cutting. It will cut the mountain in a steeper way, right? Gradually, in the middle region, there will be what? There will be steeper cutting will reduce and lateral cutting will increase. So instead of like this, it will become like this, right? So now in the gradient region or the steep region over the mountains, it is going to cut in the V shape. Water is going to cut the mountains in the V shape. Over the middle region, it is going to cut in the U shape because it is going to cut sideways, right? Lateral erosion will take place, right? So later on at the old stage, see, this is in the mature stage. At the old stage, there will be pure plain, there will be nothing. Absolute plain will be there at the old stage. So these are the three stages of the water river formation: mature, young stage, mature stage, and old stage. So here, when all this steep cutting, lateral erosion, and complete floodplain comes place, so there will be some rocks which will be left over, which won't be cut. Those rocks are called as monad knocks. Monad knocks are the rocks which are left without cutting, right? Without erosion, monad knocks. Next you have these plains which are reduced to absolute plains by the rivers are called as penny plains. Penny plains are the stream erosion. Because of the erosion of water, whatever the plain is formed, that is called as penny plain, right? So the first is youth stage. Youth stage, there will be V-shaped valleys. In the youth stage, there will be V-shaped valleys. So in the mature stage, there will be U-shaped valleys, and in the old stage, there will be flood plains. Flood plains, right? Flood plains means absolute plain, right? These are the three stages of the water. So, but in the youth stage, there are some points which you should know. Stream divides are broad and flat. Means what? Here one stream is flowing, right? Here on the same mountain, there will be, here one stream is flowing in this valley, and in the nearby, there will be one more stream is flowing. So the gap between these two streams, it will be what? It will be actually wide, right? The gap between the broad and flat. So the gap between two streams will be wide, very wide, right? So when it comes to in this region, in the youth region, you will find waterfalls. There will be waterfalls will be there in the youth region, and also there will be rapids. Rapid is a smaller type of waterfall. So only in the mountains you will find the waterfall and rapids, that is in the youth region. Youth or the youth stage of the river. Then coming to the mature stage, I told you there will be lateral erosion. Because of lateral erosion, there will be side cutting, right? So here the gap between two streams, it will reduce, right? So interstream areas will reduce in the mature stage, right? Gap between two rivers if they are flowing, right? In the old stage what happens? There will be pure flood plains. There will be no U-shaped valley, V-shaped valley. There will be absolute flood plains, right? Okay. So next is erosional landforms. What are the erosional landforms with respect to river? First is the valleys. Valleys I have told you, V-shaped valleys. So this is also a valley, right? Between the mountains, the space is called as valley. So valleys, initially I told you, initially there will be rills. Rills will get converted into gullies. Gullies will get converted into valleys, right? So there are V-shaped valleys. Then there are gorges. So this is in the Kaveri river. Gorge means, see, both the sides there will be parallel. In the valley it will be V-shaped. In the gorge it will be, both the sides will be parallel, right? So this is a gorge. Next you have canyon. Canyon means this is a canyon. See here there is a valley type of a thing, whereas it is meandering. So what is meander? I will discuss, right? So this is a what? Canyon. Where do you see the canyon? This is in the Grand Canyon of USA. Grand Canyon, very famous. Many movies have been shot there, right? So in the gorge, the distance between this and this is similar. Distance between two rocks. Here, the distance here is small, whereas in the top, the distance is large, right? That is the difference between the width. Difference between width at the top and bottom, right? See these gorges, why there is a difference between a gorge and canyon means, in the gorges it is formed out of hard rocks, whereas canyons are formed out of sedimentary rocks. That is why there is side cutting. That is, see, because there will be hard rock, there won't be terrace-like formation. There won't be terraces like this, right? Here, see, you have terrace-like structure, right? So, because the rock material will vary, there will be sedimentary rock. In the sedimentary rock, there will be different types of rocks, because of which it is going to vary, right? So, that is the concept of valleys. Next, you have potholes and plunge pools. What is potholes? Potholes means over rocky beds. If there is rock, on that rock there will be water will get accumulated, and in that water there will be lot of sediments, rock. Because of water moving on over that small hole, it will frequently get the stones in the hole will frequently be revolving. When it is revolving, what happens? The hole will get bigger, right? So that is the concept of pothole. Pothole over a rock surface, right? See, when the rock fragments will be there in that hole, right? Because of water flowing into it, what happens? The rock fragments will be frequently moving. So it is that will increase the size of the pothole, right? So later on, this will lead to what? This will grow bigger and it will form a depression. The pothole will grow bigger in size and get converted into a depression, right? So later on what happens? See, first a small hole, later on depression. So many depressions will join. They will join and they will form a valley, right? They will, series of such depressions will form a valley, stream valley. They will get connected and a valley is formed, right? So not only here, not only on the flat rock surface, even in the waterfall region. See, let's say there is a waterfall here, right? The water is going to fall here and go like this. See, because of the force of water will be high in this region, and all the rocks and mud is going to come and hit here. Here there will be lot of churning. Churning means the rock fragments will come fall here, because of the water force is also high. It will lead to lot of movement, circulation. It is going to make this hole deeper and deeper. So this is called as plunge pool. Plunge pool, where the waterfall is going to fall on the ground, right? So this is at the base of the waterfall. Next you have incised and entrenched meanders. What is incised and entrenched meanders? So what is meander? Meander means, see, you just see this diagram. This is how a meander is. If a water is going like this is how the meander looks like. So we will, but there is two types of meander. One is erosional meander, another is depositional meander. So what is a erosional meander? So when the water is moving in the steep region, what happens? There will be at the bottom there will be erosion, V-shaped erosion, right? So first there will be V-shaped erosion. Later, when the gradient changes from steep, this is steep, from this steep to gentle gradient, if the gradient changes, what happens? Not only V-shaped, lateral erosion will also take place. Lateral means sideways erosion will also take place, right? Initially V-shaped, next lateral erosion at the mature stage, middle stage of the river, right? So because of this active lateral erosion, what happens? There will be meanders forming. Meanders means, see, first there will be a river which is flowing like this. Later on, it is going to erode this region. So the river course will change like this, right? Then it gets eroded here, right? Then it will be flowing like this. Later the river will start cutting here. So from here to this will become like this. This is how erosion will be formed, right? Did you get the concept? How the meander is formed by erosion. So this is how the meanders are formed, right? So this is actually meanders are actually found in the flood plains. So it is not found over the mountains. Meanders are actually found in the plains, plain region, right? That is when the rivers come from the mountain and travel over the plain areas. In that plain areas only the meanders are found, right? Okay. So if the meanders cut the hard rock, if they see, the rivers will be flowing over a rock. If the rock below the water is cut, if the rock is hard, if that rock is cut, that is called as entrenched meanders. Incised meanders or entrenched meanders means when the hard rock below the river is cut, that is the entrenched meander or incised meander, right? Okay. So later they will develop into so this, because of this meander, there will be many other effects also, many other things which will affect the meanders. What are the factors which are going to affect the meander? We will discuss in some time. Next we will take up the concept of river terraces. What do you mean by river terraces? See, I'll first draw the diagram. See, first water was flowing at this level. Later, water got reduced and it started flowing at this level. Right? So, what the river is doing? It is cutting downwards. When it is cutting downwards, it is going down and down. There will be terraces which are formed on the both the sides. Right? This is the concept of river terraces. When the river is going to cut downwards, right, it is going to form terraces on both the sides of the river. That is the concept of river terraces. So, river terraces are basically products of erosion. When there is proper erosion, river terraces will be formed, right? So, this is called as, this is formed out of aluminium. So sorry, alluvial soil. This is formed of alluvial soil. So here what happens, if you can match the terrace on both the sides, it is called as paired terraces, paired river terraces. If you cannot match both the sides of the terraces, it is called as unpaired terraces. Paired terraces and unpaired terraces are the two concepts. It is because of the erosion, river eroding the land, right? So when there is a terrace on only one side, terrace is there only on one side or not on other side, it is called as unpaired terrace, right? Okay. So there are many reasons for this terrace formation. One is when the water, river water gets reduced, then you can see the terraces. That is one thing. Then also when there is change in hydrological regime. Suppose the water, instead of going here, it starts going somewhere else. Then also you can see the terraces. Then also in the tectonic uplift of land, means if the land gets uplifted, then also you can see the terraces. So land gets uplifted means what? See, you have sea here, sea water here, here you have land and sea. So suppose land gets uplifted and water goes below, then you can see the terraces, right? All that is the one reason. Also sometimes land will go down and sea will come up. Then you cannot see the terraces because the sea water will get flooded. When land gets uplifted, water will go into the sea, right? Then you can see the terraces, right? So this is the concept of erosional landforms. Then you have depositional landforms. So whatever I told you till now, that is valleys, potholes, punch pools, incised and entrenched meanders, river terraces, all these are erosional landforms. What we are going to talk now is depositional landforms. How the whatever is eroded, how it is deposited. So the first concept is alluvial fan. This is a alluvial fan. See, when the river is flowing from the mountain, when it is flowing from a mountain, when it hits a plain area, when it hits a plain area, what it will do? Whatever the material it is carrying with it, it is going to deposit, right? On the steep flow, it is going to carry what? All the pebbles, cobbles, shingles, mud, right? Water, all the rocks it is going to carry with it, and everything will be deposited when it hits the surface. When it hits the surface. So when it hits the surface, whatever is formed, that is called as a alluvial fan, right? It is at the Piedmont region. Piedmont region means foothill of the mountain. Foothill means what? If there is a mountain, if there is a plain, this region is called as foothill. So in this foothill region, you will find the alluvial fan, right? This is the diagram of alluvial fan. See, here river is coming from a mountain. This is a plain. It is getting deposited here, right? So this is the alluvial fan, right? It is in the V shape, right? So when the river stream breaks into the plain of a low gradient, then there will be alluvial fan, right? So what happens? See, when there is slope, the river will be carrying lot of material because it is aided by the gravitational force. But when there is plain area, there is no gravitational force because it is plain. Gravitational force or height variation, gradient force. Gradient force. Gradient means I have told you, difference between two heights. Okay. So that is also not there. That is why the materials will get deposited. So when the river hits the plain area, the material which it is carrying, it will become too heavy. When it becomes too heavy, it is going to deposit the material, right? So you have this concept of this is a cone shaped deposit. It is called as alluvial fan, right? So, okay. So then you have deltas. Deltas means what? It is also a alluvial fan, but formed at the land-ocean interface, river-ocean interface. When the river is going to merge with the ocean, then deltas are formed, right? This is how a delta looks like. So river is coming, it is going to merge with the ocean. There deltas are formed. So deltas are also alluvial fans. They develop at a river and ocean interface. At that region, it is developed, right? So here the load, whatever the load that was carried by the river, all the mud, rock, everything will be deposited at the delta, right? So here one difference is there between the alluvial fan and the delta. In the alluvial fan, all the materials will be deposited together, whether it is a bigger material, smaller material, material with lot of weight or less weight, everything will be deposited together. Whereas in the delta, there will be stratification. What do you mean by stratification? Material with high weight. Those materials with huge weight, they will be deposited first. And material with less weight, they will be deposited later, right? So there will be clear stratification in the deltas, right? So the coarsest material are deposited first and smaller, finer material will be deposited later, right? Then you have the concept of floodplains, natural leaves and point bars. So this is a floodplain. See, here river is flowing. Whenever the river flows, whatever the material it is carrying with it, sometimes there will be flood in the river. So when there is flood, what happens? It breaches the boundary. When it breaches the boundary, it travels to the neighboring area. In the neighboring area, whatever the material it drops, whatever the soil, rocks, whatever it carries, it drops. When the flood gets over, the area that is formed is called as flood plain. This is the region next to the river. And the boundary of the river, there will be a natural ridge or a natural dam kind of a thing next to the river. That is called as natural leave. Then you have point bars. We will discuss what is point bar. So, floodplain is a major landform of river deposition, right? So, large size material are deposited first. See, here large size material are deposited first. Later on, small size material will be deposited later, right? Okay. So, when there is a flood, what happens? Water will spill over from the river to the neighboring region and it is going to deposit, right? So, they deposit all the materials. So, whatever the materials that get deposited, it get deposited in the flood plain, right? So, there are two kinds of flood plain. One is active flood plain, second is inactive flood plain. What is active flood plain? See, at the bottom of the river, whatever the plain is there below the river, bottom of the river, that is active flood plain. Next to the river, whatever the plain is formed, that is inactive flood plain. These are the two kinds of flood plains, right? Okay. So here there are two kinds of deposits one is flood deposits, another is channel deposits. Whatever the flood is going to deposit, it is called as flood deposit, and whatever this river channel what it deposits naturally, that is channel deposit. Natural deposition is channel deposition. Whenever there is flood, that deposition is called as flood deposition, right? These are the two kinds of deposits, right? Okay, so here the floodplains in the delta region, if there is a, see, in the deltas also there will be floodplains which will be formed. Those floodplains are called as delta plains. Floodplains in the delta region are called as delta plains. Please remember, right? Then you have natural leaves and point bars. What is natural leaf? The boundary of the river is called as natural leaf, right? So here natural leaf are found along the banks of the river. Along the banks there will be natural rivers. It is the like a dam to the next to the river, right? So they are the parallel ridges. There will be ridges across next to the river, right? During flooding, when there is flooding, what happens? The water will cross over this natural leaf and flow into the neighboring region over the flood plains, right? When there is flooding, right? First there will be, in this region, large size material will be dropped. As the distance get more, small size material will be dropped here when the distance grows from the flood plain, right? Okay, next there will be now one more thing called as point bars. What are point bars? See, in the meanders, I told you, in the meanders, as and when the river flows, as and when the river changes direction, see, earlier the river was flowing like this, right? Later it changed direction and flowed like this. Later it changed direction and went like this, and from here it went like this. Later on it is going like this. Next is going to change to here, right? So whatever the boundary that has been left over, this boundary is called as natural leaf, or sorry, this is natural leaf, this is point bar, right? So it is in the pointed form, right? That is called as point bars, right? So these point bars are also called as meander bars. See, because of meandering only, these point bars are formed. That is why it is called as meander bars, right? They are found on the concave side. See, this is the concave side, right? There is two sides. One is concave and convex. So this is the cave side. So this is the concave side. This point bars are found on the concave side. Here you have convex side. Convex side there is erosion, whereas concave side there is deposition from the river. As the river moves this side, it is going to erode the convex side and deposit materials on the concave sides, leading to the formation of point bars, right? Okay. So next you have the concept of meanders. So what is a meander? This is the diagram of a meander. See, earlier the river, see, earlier was flowing like this. Now it has changed the direction. Here there is slip of bars. See, from here the river has slipped to this position, and from here it has slipped to this position. Here it has left the point bars. These are the point bars. See, when what happens? Earlier the river was flowing like this direction. Suddenly there will be some cross section here. So river is flowing like this. Okay. So what happens? Suddenly it starts flowing like this. Because of some reason, because there is some gap here, it starts flowing like this, in this direction. So this entire thing is cut off. So when they are cut off, there will be this region, there will be water left out. This is called as oxbow lake. In the meanders, out of meanders only oxbow lakes are formed. Here there is one more oxbow lake. So this is slip of bank. This is the concave bank. This is the convex bank, right? This is the concept of meanders. So Rivers do not flow in the straight way. It flows in a curvy way, right? So this leads to what? Meander formation. What is responsible for meander formation? One is it is formed over a plain region, not over a steep region. But in Jammu and Kashmir, you find the meanders forming in the steep region as well. Jhelum forms over Jhelum river is the only exception in India where it forms in the youth stage. See, meanders are not found in the youth stage. They are only found in the mature or old stage. But Jhelum meanders on the river Jhelum, you find the meanders in the youth stage, right? So that is one thing. One is there should be proper flat gradient for meander formation. Then there should be what? There should be lot of unconsolidated material. Unconsolidated material means, so the rocks, soil, everything should be there with the river, which should be able to be deposited. That should be there for the meander to be formed. And third, there should be Coriolis force. See, you know what is Coriolis force? Coriolis, see, Earth is rotating. Because of Earth rotates from west to east. So when it is rotating from west to east, what happens? In the northern hemisphere, whatever the winds or the movement of water, it takes place in the clockwise direction. And in the southern hemisphere, it happens in the anti-clockwise direction because of the rotation of Earth. That force is called as Coriolis force. So meander is also formed because of the Coriolis force. Coriolis force is the third reason responsible for meanders, right? Okay, so initially there will be small curvatures. Initially in this straight river there will be small curvatures. It slowly gets increased and gets formed into a proper meander. Small curvature will get converted into a proper meander, right? So in the meander there is lateral cutting. There is no steep cutting. The river cuts horizontally across the region. It is not going to cut vertically downward. It is going to cut horizontally in the meanders, right? Okay. So in this region, there will be deposition. Here there will be deposition. Here there will be erosion. Convex side there will be erosion. Concave side there will be deposition, right? So this is a concept. Okay. So next you have the next depositional form, braided channels. What is braided channel? See, when there is a delta, when the river comes like this and an alluvial fan is formed at the delta. See, river is just doesn't go and flow into the ocean just like this. Or how does it go and flow into the ocean? It is going to flow in multiple thread form, right? So these multiple thread form of pattern of river flowing into ocean is called as braided channel, right? That is the concept of braided channel. So why do these braided channels are formed? See, these braided channels are formed because rivers carry some material, coarse material, rock, soil, all those things, mud, everything. This will be deposited because see, this delta is formed on the plain region. When the delta is formed on the plain region, the rocks, mud, soil, that will be deposited on the plain region because there will be no force to carry them, right? When it is deposited, what happens? See, this one rock is deposited here. When there is a rock which is deposited here, it will deflect the water into two directions, right? When a coarse material this is a river, there is a rock here, it is going to divide the river into these two directions. So the rock in the braided channel, there will be deposition, coarse material will be deposited, it is going to change the direction of the river, right? Okay, So what happens? There will be one deposition, and later on, because of one deposition, there will be lateral erosion. Lateral erosion means sideways erosion. When there is sideways erosion, there will be many thread-like structures which will be formed. So that is the concept of what? Braided channel, right? Okay, it is a thread-like pattern. Next you have groundwater. So first we spoke about the normal water. The last concept of the day, groundwater. What is the erosion? What is the deposition with respect to groundwater? See, when it comes to groundwater, we are just not interested in what the groundwater does. We are interested in what is the landform. What is the landform that the groundwater is going to give birth to? What landform does the groundwater is going to form, right? So, see this surface water which is flowing on the surface, what does it do? It is going to percolate inside. It is going to get inside the ground, right? So when it through what does it get into the ground? It gets into the ground via various cracks, joints, right? Various cracks. It is going to go into the ground, and it will flow along the bedding plane. Bedding plane means, see, there will be some plane area within the, there will be one plane, one or multiple planes within the earth, bedding planes. So via cracks it is going to get into the ground, and along the bedding planes the water is going to flow, right? So this is how the water will get into the groundwater. Surface water will get into groundwater, right? There will be first downward movement, later on horizontal movement. Downward movement from the surface water. Once it gets into the ground, later on it is going to move horizontally along the bedding plane, right? Okay, so here this groundwater, whatever the landform it is going to form, it cannot be seen in hard rocks. Groundwater cannot erode the hard rocks. So what kind of rocks does the groundwater erode? It is going to erode the two types of rocks. One is limestone, another is dolomite. Dolomite and the limestone are the two types of rocks that the groundwater is going to erode, right? So these limestone and dolomites, what is the speciality about these rocks? These are formed out of calcium carbonate rocks, right? So they erode these calcium carbonate rocks, limestone and dolomite, via two processes. What are the two processes? Solution and precipitation. Solution means, see, I told you during the chemical weathering process. So water will, some material is going to mix with the water or acid. It is going to form solution. That solution is going to erode the limestone or dolomite. That is the process of solution. Next is, one is solution. The second one is precipitation. Precipitation is, this material is getting collected somewhere, is precipitation, right? Okay, so this when the limestone or dolomite region is eroded, right, the landform that is going to form is called as karst landform or karst landscape, right? This karst topography is very, very important. It is formed out of the erosion by groundwater in the dolomite and what? Limestone region. Next you have erosional landforms because of groundwater. What are the erosional landforms? You have pools, sinkholes, lapis and limestone pavements. What are the pools? See, pools means they are shallow depressions. If there are shallow depressions on the ground, on the dolomite or dolomite or limestone surface is there within the ground, they are above the ground. So first what they will do, because of water will have some acids, first there will be some small pot like hole will be formed, that is called as pools, right? So first there will be a pool, that pool will get converted into swallow hole. This is a swallow hole. First there will be a depression like this which is called as swallow hole, right? So this swallow hole will later get converted into a sink hole. Sink hole means it is going to sink. The material at the surface is going to sink, right? And there will be a collapse. So that is known as sink hole, right? So swallow hole will get converted into a sink hole, right? So later on, if the sinkhole is, there will be little sinking, whereas entire material is going to sink together, then it is known as collapsing. The entire material collapses, it is known as collapsing. First there will be swallow hole, next there will be sinkhole, later on there will be collapse hole, right? So sometimes in this sinkhole there will be water, right? If there is water, if somebody goes and steps into this, they are going to go into the ground, right? They are going to disappear, right? That is the sinkhole. That is why it is called as sinkhole. So collapse sinks are also called as dolines. Collapse sinks, another name is dolines, right? So when sinkholes and dolines, see these sinkholes and collapse sinks, they join because these collapse sinks, if there are multiple collapse sinks, so these multiple collapse sinks will join together, and when they join together, it is known as valley sinks. Multiple collapse sinks join together and they form as valley sink. This valley sink is also known as uvalas. Valley sinks also known as uvalas, UVALAS. So this is the valley sink. See, there are sinkholes. All these sinkholes is going to join and form a valley sink or uvalas, right? This is a uvala, right? Then you have this concept of lapis. Lapis means, see, when there is proper removal of the material, if there are one or two projections like this, one or two material which is not eroded, that is known as lapis, right? And then more you have one more concept, you have limestone pavement. Whatever the pavement or the flat region that is formed out of erosion, it is called as limestone pavement. Next you have caves, the concept of caves. This is a cave, right? Within the earth there will be a cave formation. So what is this caves, right? So in this, wherever there is limestone or dolomite, what happens? These rocks are not strong. It is actually a sedimentary rock. So some rocks will be stronger, some rock will be weak. Because of the carbonic acid in the water, these dolomites or the limestone is going to collapse and a cave is formed, right? So it is because of what? One is the rocks will be formed out of multiple materials, hard rock and soft rock, and water will percolate down to it, water will get into it, and it is going to do what? It is going to dissolve the limestone. When the limestone is dissolved, what happens? Caves will be formed. When limestone gets dissolved, there will be proper cave formation, right? So if there is only one opening, it is called a cave. If there are two openings, it is called as tunnel, right? So this is with respect to erosional landform. With respect to what? Groundwater. So what are the depositional landforms? So how does the groundwater deposit? What are the landforms it is going to create when there is deposition? So the depositional landforms, you have what? So I will discuss, there are three depositional landforms, right? So when the limestone or the dolomite is dissolved in the water and it is taken somewhere and there is new deposition. The erosion is already done. If a deposition takes place somewhere, right? What are the landforms that are formed? So the erosion and deposition, which is the material that is moving, it is calcium carbonate originating in the limestone or dolomite, right? So there are three types. One is stalactite, stalagmite and pillars. What are stalactites? Stalactites, see, if there is a, see here, this is a depositional landform. This one, all these things. So these stalactites are pillars hanging from the above. So calcium carbonate pillar forming from the above are called as stalactites. They hang from the above. Stalagmites, see, it will be form of a triangle. Here it will be bigger, later on it gets smaller. Stalagmites are, it is originating from the bottom. See what happens, here water will drip from the, first there will be stalactite formation and water will be dripping from the bottom, and when the water drips into the ground, there will be a new structure forming. That is, this new structure is known as stalagmite. Stalactite and stalagmite, over a period, both of these will merge. Both of these will merge and there will be a stalactite and stalagmite will merge and there will be a pillar formation, right? So this is the depositional landforms with respect to groundwater, erosional and deposition landform, right? So we will end the class here. Tomorrow we will talk about the geomorphic process, geomorphic agent of glaciers. Glaciers, wind as well as waves, and three things are there. Glaciers, waves and winds, right? If we do these three things, the landform chapter is done. Then we will move to climate change and other things, right? Atmospheric circulation and other things. So if you have any doubt, please put it in the comment section, or you can contact us on our Telegram channel, VHS Education Forum. Please make good use of the classes, and if you have any suggestions, you can reach us through our Telegram channel. Also comment in the comment box, right? So please take good care of your health. We will meet again tomorrow. Jai Hind. Namaste.